Hey, welcome back, everybody. Savas Algebra 2, Lesson 7-5, Trigonometry. I may not even assign this to most of my Algebra 2s, but I would give it to somebody that needs a little extra stretch, that is looking for a challenge, going on to pre-calc, higher levels. So find the equation of all vertical asymptotes for the following. So -4 out in front, I know that's my amplitude. I know that it's going to be flipped. I know that the cosecant here is the reciprocal with sine. Remember, we had tangent, and cotangent being reciprocals. Tangent 1 over cotangent, and we had sine and cosine. They always pair up with a non, so this is with cosine's with secant and sine is with cosecant. We have cosecant here. So we're talking about 1 over sine. It's talking about reciprocal or asymptotes. So the asymptote, remember what we're talking about here then would be the fact that when is the sine equal to 0? Well, if you go back all the way to your unit circle and sine, if you put one of your reference triangles in, sine being opposite over hypotenuse, so, and the opposite side is your y side over your hypotenuse 1. So sine was always 1. And I'm sorry, sine was always y. Sine is your opposite, y over 1. And so sine is always y. So if we're talking about cosecant, we're talking about 1 over y, and we're talking about where are the y's equal to 0. Well, my y's are equal to 0 on the x-axis, right? So if I'm right here, so on my 0, or I'm over here on my pi, or when I get back to 2 pi, or if I was doing negative rotations, a negative pi and all the way around to -2. So that's where all my asymptotes are, and they ask, find the equation for all vertical asymptotes. So the vertical asymptotes here, for any integer k, it's not all my pi's, but it's the odds and the evens. So in k times pi, yeah. And if you needed to, I went over before I started recording and looked at, okay, just take a look. What's my, turn off some of these here. What does my cosecant graph look like? It looked like that. You know, you've got to kind of use some of your own skills here to kind of remember, well, where are, we're talking about radians here, so we're talking about the pi's. Obviously, we've got an asymptote at 0, but then what is this right here? So it's, you know, someplace more than a -3, so that would be your negative pi. And if you came over here and did the same thing, so over here, what's a little more than the 3? That must be my pi. If you want to know the low point, that's going to be like your pi over 2. Or this high point, your 3 pi over 2. And those are also what number? That's your -1 up to your 1. So some of that's, you know, and put in whatever else you need. So if you wanted to take a look and say, well, wait, where is the -4 cosecant then? So the negative flipped it, it stretched it by a factor of 4 compared to the regular one. So flipped down here, flipped, get the right pen, flip down here and stretch it by a factor of 4. Also, well, where's my pi over 2? So here's the pi over 2. That's what we labeled, so that's matching up. My pi over 2, that's that black line right here that it just added. And then also maybe where's the graph, where's pi at? There's my pi. And you can put others in to help you figure it out, but whatever you do, keep after it. You can discover, play with it, but k times pi, that's where all those reciprocals are located. So let's put that in there, and we should be good to go there. K and a pi. All right, so hopefully that helps you out. Again, whatever you do, we could do transformations of reciprocal functions or specifically cosecant. Look them up in YouTube, search, find out all of your transformations, or just play with it like I was showing you there in Desmos. But keep after it. You can do this. If you have questions and you're in class, bring them to me. I'll give you a hand. Hope you're having a great day.